Satellite data by NASA and the National Snow and Ice Data Center at the University of Colorado Boulder shows that the 2020 minimum Arctic sea ice extent likely occurred on September 15th. Satellites are useful to scientists for tracking the extent of Arctic sea ice. I sat down with Dr. Andrew Carlton, professor of physical geography in the Department of Geography at Penn State, to discuss satellites used in the Arctic and this year's minimum Arctic sea ice extent. The most useful type of satellite imagery for viewing the Arctic and Antarctic is passive microwave radiation.
Microwave radiation can be sensed at night and also through clouds that are not very thick. So this meant for the first time that in the polar regions we could have sort of 24/7, if you like, coverage, or at least it wouldn't be affected by the winter polar night. We would have coverage of the polar regions in terms of the sea ice condition.
Satellites have been monitoring the extent of Arctic sea ice since the 1980s. Scientists have found that since then, Arctic sea ice extent in the summer and the winter has been on a steady decline.
As both the air and the ocean warm up, it just makes it more difficult in consecutive years or in consecutive fall and winter seasons after the summer for sea ice to form. And when it does form, it tends to be thinner. We've noticed a thinning in the sea ice over time, as well as a decrease in the area.
The ice albedo feedback loop can help explain why the September 2020 Arctic extent of 1.44 million square miles is believed to be the second lowest minimum sea ice extent.
The reason that we have this downward trend is primarily because of that ice albedo feedback. And so as you get less and less sea ice forming in the wintertime, this means that, of course, there's going to be less in the subsequent summer. And this means that the darker ocean is exposed to solar radiation, or a larger area of the ocean is exposed. The Arctic Ocean is exposed to the solar radiation. That means there's more absorption of the solar radiation that continues to heat up the ocean, as well as the air temperatures.
Scientists believe that with this downward trend, we may have summers with no sea ice at all in the near future.
Once it starts, it's very difficult to reverse it. And so a lot of models are predicting by about 2035, we will start having summers with no sea ice in the Arctic basin at all.
In addition to iceless summers and a general warming in the Arctic, there are a multitude of dire consequences of climate change in the Arctic region.
There's a number of consequences, as I said, increased temperatures, more wildfires in higher latitudes, vegetational change, the melting of the permafrost. And permafrost melting has a couple of main consequences. One is that essentially buried methane is released into the atmosphere, and methane is a potent greenhouse gas, of course. The other thing is that the melting permafrost destabilizes the ground surface. It means that structures that you build are going to become unstable, and roadways, buildings, and so on. So you can have lots of problems that way. And as I also mentioned, sea level rise. So there's a number of problems that come from the accelerated warming in the Arctic region.
As global temperatures remain on the rise, we can continue to use satellites to keep an eye on the Arctic. For Weather World, I'm Salix Iverson.